Hello, let's do the New York Times Hard Sudoku for December 5th, 2023. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, we have two fours looking into this box, and this four looks up. So there's only one place in this box a four can be, so it must be there. We call that a hidden single. The reason the terminology hidden versus as opposed to naked. Naked would be if I were to fill all the candidates this could possibly be. So let's just go through that real quick. It can't be one or two. It could be 3, 4, 5. Can't be 6 or 7. Can be 8 or 9. So this is not obviously a single, right? If it was down to just 4, if I went through all that and I saw everything except 4, that would be a naked single. Instead, it's a hidden single because for reasons that are not obvious, if you pencil everything, this is the only place for 4 in the box. But using the techniques that we use, we actually find it easier to find hiddens a lot of the time. So it's pretty easy to see if you scan this way that 4's, if you, instead of scanning from a center mark centric point of view, you scan from a given point of view, or like what's eliminating from where point of view, we can just see that 4's look into this box in such a way that forces the 4 in this box to be here. It can't be anywhere else. And a hidden technique will always remove candidates from the cells that you from certain cells, as opposed to naked techniques remove candidates from the other cells in its row, column, or box. All right, anyway, so I thought I'd explain that since I had the opportunity. 6's go somewhere over here. And we're just looking for basically 2 digits that match up, right? So I'm looking at the 4. I saw the 4 matches up. I'm looking for another 3. I'm looking for another 1. We see the 1s. These 2 1s look in. Now, what I use these corner marks for with these 6's is I use them to tell me that within this box, 6 was down to just these 2 cells. Now what I'm going to be doing is I'm placing a hidden single 1, right? There's only one place for 1 in this box, so I'm placing a hidden single 1 here. This can only be 1 because it's the only place in the box for a 1, and the box needs a 1. Now I've used up one of those 6 corner marks. This is why we use the corner marks to do box-centric logic. We can immediately know that this is a hidden single 6 without having to rescan everything. Otherwise, if I didn't have those corner marks, I'd have to later notice, oh yeah, I remember these 6's were restricted. Oh, that 1's occupying one of the spots. Now that's a 6. It's a huge time saver to notate interesting things that you've noticed. And the things that I tend to notate and find interesting are when a digit is restricted to 2, sometimes 3 places in a box. I use corner marks for that. And then if a cell is particularly restricted in what candidates it can be, 3 or fewer, usually I will use center marks for that. So there we go. That's kind of the main technique. It's a variant of Snyder notation. I don't know if it's exactly Snyder notation, but it's similar. This 5 is looking up into this box, so 5's in one of these 2. I'm looking for, yeah, this 2 looks in, so 2's in one of these 2. Now, because we have 5 and 2 corner marked in this box, and we know there's only 4 digits remaining, this cell here is very suspicious, because we can just do the math, right? There were 4 candidates remaining, and this one's not 2 or 5. So at best, it's down to 2 different digits. So those 2 digits are going to be the 4 digits that this box needs, minus 2, 5, and then maybe minus something else it sees in its row column, although it doesn't appear to be the case. So 1, 2, 3, 4, 5, 6, 7 are accounted for. And so this is down to 8, 9. So we're using center marks to say, hey, this cell's kind of interesting because it only has 2 possible values. We can use that to form naked pairs. We can use that later if we place an 8 or a 9, maybe in this column or in this row, then we can then just immediately fill that as a naked single. Okay, so see, this 7 and 9 looking up is almost interesting because there's only 3 places for them. It's tempting to do 7, 9 corner marks here, but I know that I'm going to make a mistake later, and I'm going to scan this and go, ooh, I have a 7, 9 pair or something. And that's just not the case. Or 7 and 9 are restricted in that column or this row, and that's just not the case. So even though it could be useful to notate that, I don't have a good way to notate it, and I'd rather not confuse myself. So I just don't notate it. And we'll just come back and look at that every once in a while. There's a balance there. So the other thing I can look for up here are things called crossings. So if I find one, I will explain one because it's much better to have an example. I'm sure there'll be one somewhere in this puzzle. All right, I don't see one immediately. Okay, we're going to move on to the next band because I'm not seeing much more to do here. One thing we could do is we could think about this row because it's down to 4 digits. But just by counting, if we center mark anything with 3 or fewer left, if there are 4 candidates possible per cell max, that's a good chance. There's a good chance you're going to get 3 or fewer in some of these. So the digits that are missing are 3, 5, 8, 9. So this is down to 5, 8, 9 because it can't be 3. This is down to 3, 5, 8, and this is down to 3, 5, 9. This early on, I don't normally look for 3 or fewer restricted cells because it can clutter the board and harm the ability to harm your ability to scan for hiddens. But I'll leave those for now. All right, I found a crossing, so let's explain that. So you look for crossings when you have 2 digits or 2 givens in a box, in the same box, that share a row or column. So this 8, 1 is one example. They share a row. So if it's because they share a row, there's going to be a single column. I'm going to actually mark those green here. And I'm going to mark this column purple. They share there's a single column that they don't occupy. What we're going to do is we're going to unpurple all the empty cells, and then we're going to unpurple all of the cells that are already in the box somewhere. So 5 and 7, those are our candidate digits. Then we're going to look over in these blue cells over here, the 2 rows that the green doesn't occupy. And again, we're going to ignore anything that's empty, and we're going to ignore anything that's not 5 or 7. We're looking for 5s and 7s over there. Now, obviously, you normally wouldn't color that, but here, the 7's eliminated because there's no 7s over here found. But there was a 5 found. And so once you find this, it is a crossing. So this 5 looks in, this 5 looks up. And the green cells, because of the way we looked for this, are not 5 and occupy 2 important places that 5 could have been. So that means in this box, 5 is limited to 2 cells. And that's a non-trivial deduction that gives you non-trivial results. It'll always cause pointing. Unless you ended up having 2 5s, like a 5 here and a 5 here, in which case you should have just had scanned that without finding the crossing. But anyway, because 5 is limited to these 2, this does what's called pointing. Now, the logic behind pointing can be explained in a few different ways. The way I'm going to explain it today is where is the 5 in box 6? And it's not a trick question. The 5's in one of these 2 cells. We just marked it. Well, those 2 cells are both in row 6. How many 5s does row 6 get? The answer is exactly 1 5. That's Sudoku rules. So because there's exactly 1 5 in row 6, and we know that box 6 is getting the 5 from row 6, the rest of row 6 cannot be a 5. Because if I put a 5 here, for example, I have now excluded 5 entirely from here. So the way people like to think about this as pointing is you kind of have these 2 line up in a box, these 2 corner marks line up in a box, and they point to the left, eliminating 5s from the rest of the row. They could also point right if they were in the middle box or the left box. So these are not 5, and this 5 is looking in here. That places the 5 in this box. I'm going to get rid of these screens. We can look for more crossings as well. Like this 6, 9 is right for a crossing, but there's no 4s over here. This 5, 6 is right for a crossing on 1s, for example. So 1 is in one of these 2, and we always follow up when we find that. So those ones look down, that one looks in. So there's a 1 in one of these 2. It's always going to point, so we always want to look at the consequence before you forget that we did it. Any other crossings on this 5, 6? We're looking for 7. Yeah, 7 as well. So 7 looks down, 7 looks in. So this is a hidden 1, 7 pair. What do I mean by that? Well, first of all, I could have just pencil marked 7s here in the corner. Corner marked 7s, I should say. And left it there. But what we can notice is that these 1s and 7s overlap. So it's two different digits overlapping in 2 different cells and nowhere else. And so what this is telling us is within this box, 1 is limited to these 2 cells, can only be in these 2 cells, and 7 is limited to these 2 same cells. So 2 digits for 2 cells. That means that that's a hidden pair. And remember, hidden techniques remove other digits, other candidates from those cells. So there's no reason we should have been able to say, sorry, let me put it this way. There's no obvious immediate reason this can't be a 2, right? There's not other 2 in its row, there's not another 2 in its column, and there's not another 2 in its box. However, if we examine it more carefully, where do we put 1 and 7 in this box? Well, none of them can go there, none of them can go there, and none of them can go there. So we'd have to put a 1 and a 7 in this cell. And that's not going to work. The box is going to have one of those excluded. So this actually can't be a 2. It can only be 1 or 7. So hopefully that's clear. This 3 now looks up here. This 3 looks down. And 3 was removed from these two because of the 1, 7. Well, I guess it was never removed from them because it could never have been them. Never mind. That's a 3, just it has been. This is a triple at best. 2, 4, 9. All right, I am going to fill that for the simple reason that this can't be 9, so it's down to 2 cells. And then the 9's over here, which is good to mark. Let's see. Okay, so crossings are extremely useful. They found us this 1, 7 pair. I'm looking for anything else that might be useful here. The 7, 9 could have a crossing. 5, 6. Nope, they're all already placed in the box. Now, if this ends up a 1, that would place 1 here. It's an interesting deduction, at least. I don't think we can use it. However, I just scanned this 1 and I saw that we have a crossing on this 8, 4, and that's going to be really useful because that means one of these two is a 1. Oh, and I just scanned again and I saw that 5 does the same thing. So we have another hidden pair here. This is a 1, 5 hidden pair. I'm not going to explain it again. You can go back to the 1, 7 if you're still confused. But this is a 1, 5 pair now. This is a 1, 5 pair. This can't be a 1 because if this was a 1, these would both have to be 5 or one of them would be blank. Both of which would violate Sudoku rules. So that places the 1 in this box here. Can I do anything else with this? Yeah, this 3 looks in. So 3 is in one of these two. So these are not 3s. It's hard to mark not 3. It feels important though. Why don't I think about that later? I'll just try to remember that we have those 3s there. Because I haven't really finished scanning. I've only scanned this band technically. I've kind of skipped around a little bit, but as I found things. But technically, I'm still on this band out. So I have 3 bands and 3 stacks to scan, and I'm 2 out of 6 right now. So there's probably more to find that's obvious. So let's move on to this band here. There are no repeats except the 1s, which we already got. 3s don't repeat, 5, 7s, but there might be crossings, like on this 1, 5. Yeah, there's crossing on, with the 4 here. So this 4 looks down, this 4 looks in. I found it the same way I found all these other crossings. It puts 4 in one of these two. And that places the 4 here. Because this 4 looks left, these two 4s, they point left, and this 4 looks down. And I purposely use the word look. Look is what givens do. Point is what corner marks do. I don't know if that's essential to denote that difference, but I feel like being explicit with terminology aids in communication if you understand how that terminology is being used. I'm going to think about this column because it's down to 4 and it might be restricted. I'm not sure. That's why we're looking. 2, 7, 8, 9. So the 7 is down here. Otherwise, no. Okay, well, worth a shot. This 1, 7 feels useful. So there's 4 left here if we basically, oh no, so there's 5 left here. Oh, that's not as nice. 2, what I was going to say is we know where the 1, 7 are, so we don't need to count those. 2, 3, 5, 6, 8, 9. Wait, 2, 3, 5, not 3. 2, 5, 6, 8, 9. I was like, that's too many. 2, 5, 6, 8, 9. I'm not super happy with that. We're just not going to mark anything. All right, so I scanned horizontally. We're going to scan vertically. 1, 4. 4 is over here somewhere. Mark that. 3, 3, 5, 6. So the 2 6s look down. So 6 is down here. We've got 14 minutes on the clock already, but it's because I'm decided today is the day to explain things thoroughly again. So hopefully this is useful for some of my newer watchers, or just a refresher for people. Sometimes people enjoy that. Hopefully you are enjoying this. There's 2 4s here. So 4 goes there. We do have the 3 looking up. I'll look at that in a second. I still want to finish scanning in case there's something obvious to find. 2 6s here. That is obvious, yep. That's a 6 and that's a 4, so that's not a 6 and that's not a 6. That places this 6 and this 6. 6s are done. Quite nice. So now there must be something to do here, right? The 8 looks in. That puts an 8 in one of these two. So that 8 looks up with this 8, putting an 8 in one of these two. In general, we need 2, 3, 4, and 8 here. Neither of these are 4. So this is 2, 3, 8. The top one's not a 3. So those are worth marking, I think, at this point. I basically have finished scanning all my bands and stacks. So I'm going to start looking for restricted cells. And the place I start is rows, columns, boxes, usually with 4 or fewer left is a good place to start. So like this row here has 4 left. So we just think about what they are. They are 3, 7, 8, 9. And so like neither of these are 8. So they're already down to 3, 7, 9. This is a naked, wait, sorry, I said that wrong. Let's redo it. 2, 7, 8, 9. This cell sees 7, 8, and 9, right? So this can only be 2. That's a naked single 2. That's why we look. And then we're left with 7, 8, 9 here. And this one can't be 7, so that's down to 8, 9. I think I'll just write 7, 8, 9 here, though. That's not 8. Like, we're looking for stuff to match up here. Okay, I'm seeing these can't be 9, and the column needs a 9, and they also can't be 3. And I'm trying to keep in my head that we have these 3s pointing. These aren't 3s. So I think it's time to pencil them, because I know they can't be 3 or 9, so there are at best 3 digits left. Do they see anything? Anyway, let's just do it. We need 2. They can't be 3. We need 4. Oh, sorry. We have 4, 5, 6, 7. Wait, they were down to 2, 8. How did I miss one? Should have been 4. Oh, yeah, it was 4. 5 minus 2. So what's the other digit they can't be? The 7. It's also the 7 that's out. This can't be 7. This is down to 3, 9. I think this can be any of 3, 7, 9. And then this is 7 or 9. Okay. So what's this 2, 8 do? It leaves a triple behind. So these are 4, and then there's 2 more digits. It looks like it's 1 and, what else? 3. So 1, 3, 4. Okay, what else do we have here? Okay, I'm thinking about this 2, 8 pair. Yeah, this 2, 8 pair with this 8 look up. So 8's in one of these two. And now what we can see, there's a few ways you can see this, but 8's are already interesting, right? Up here, because we've got corner marked 8's here, corner marked 8's here. Now, 8 can't be up here, right? So one way to think about it is, where's 8 in this row? This can be a little hard to spot, but because we have this corner marks here, we know 8's not here either. So if 8's not any of these, and then we have these corner marks that tell us 8's not here. So 8 is going to be here. This is a hidden single 8 in the row. But another way you could see that is looking at these cells here. I'll mark them green for a second. This is what's called like lining up, or I don't know if there's other terms for them, but this is just an inverse way of seeing the hidden single or the claiming in this row is within boxes 1 and boxes 2. So 2 boxes that line up. These share a box row, right? 2 boxes that line up. The 8 has been limited to rows 2 and 3. So they kind of line up in rows 2 and 3. They can't be in row 1. And so because of that, the logic people like to use for the lining up, if you don't want to use, hey, let's just look at row 1 and see that 8's there, you can see that uses up the 8's for rows 2 and 3. Rows 2 and 3 have 2 8's in total. One of them's here, one of them's here. They're only in green, which means they can't be over here. So some people like to think about that as eliminating 8 from the rest of these. So this can't be 8. And then now our corner marks tell us that 8 goes here. The result is exactly the same. The logic is just inverse of each other. There's a lot of that going on in Sudoku, where you can think about the same piece of logic in 2 ways. There's basically 2 sides of the same coin. Whatever makes more sense to you or is easier to see, use that. For me, I like to just look at the row they're not in and see what happens to that row. But not everyone likes to think of it that way. Okay, so I want to think about these four. We need 2, 4, 8, and 9. We know these aren't 9, so these are 2, 4, 8. I'm starting to just fill in cells that have 3 left. I feel like we're getting close. Let's see, I got this 8. What can I do with it? Not much, to be honest. It occupies this spot. That's probably the best thing it's going to do for us. So what does occupying this spot do for us? Honestly, not much right now. Okay, I'm going to look for something else to do. Um, 2, 7, 8, 9. How about this row? We need 2, 3, 5, and 9. We know this is not 3, so this is 2, 5, 9. These are not 5. 5 in this row is not here, and it's not here. So 5 is placed in this row. It's hidden in the row. The remaining digits here are 2, 7, 8, 9. So these are 2, 8, 9. You'd think that would do something. This is any of them. All right, I got this 5. What's this 5 doing? We already knew about that. Wow. The rest of this row is 2, 3, 9. The 2's over here. So this is not 2. So this is 3, 8, 9. Okay. Come on, give up your secrets, puzzle. I'm 21 minutes in. I spent a lot of time explaining, more time than usual. But still, I'm 21 minutes in. Usually done by now. This is not a 1, so this is 3, 5, 8 as well. I'm looking for the key cell that's going to finish everything, but I'm not sure. Okay, I gotta relook at like corner marks that I have, because I suspect I might have just not applied one correctly. 5 being one of these two, 2 and 1. Yes, and that's exactly what happened. These 2's point here. They point right, so this can only be 3. There we go. So those aren't 3s. This is down to 2, 4. That's a 2, 4 pair, so this is down to 5. So it can't be 1, 2, 3, 5, and 7. Yikes. Okay, what's this 3 get me? It gets me this 3, and it gets me this 8. It's the only place in the box for 3. This is the only place in the box for 8. That's a 1. There we go. Okay, so had I actually paid attention by pointing 2s, I would have been finished a little bit faster. But that's all right. 5, 7, no one is perfect. We strive to be as good as we can, and we strive to improve, but there's always going to be room for improvement. Let's see, that's a 2, that's a 3, that's a 9, that's 7 and 3. That's a 7. There's a 2 in one of those, but I don't think I need to be marking those anymore. This is the place for 2 in the column. We get the 7 here, 5 and 9 here. This pair is 5 and 9 as well. So this is a single. It's the only place for a 7 in the row. That's 5 and 7. That's a 9. That's 8 and 5 and 9 and 5 and 9. 2, 8, 4, 9, 2, 8, 2, 4, 9, 8, 2, 9, 8. And then up here, we need a 2 and we need a 5. And we're done with a large time. But that's okay. I decided today would be the day that I would explain some of the more basic stuff that I tend to skip over sometimes. So hopefully that was useful for some of you. Obviously, if you don't sit there and explain every technique, things go a little bit faster. Also, if you pay attention to your own corner marks, things go faster. At some point, these corner mark 2s had an effect on this box that could have been marked with corner marks, I think. Or it could have been marked from the very start, maybe. And I did not. And that's a failure on my part to have not noticed those 2s. But hopefully this was useful. And of course, if you enjoyed this content, then why not leave a like, subscribe, and a kind comment below.